like that. So you give it is like this, you present a document to the classifier, it returns a class level, so to say, of the document. Okay. So I'll give examples what class levels might be. And then to obtain this classifier, we have a learning phase, where what we do is that there is a set of documents with known class level. That means their class levels are already marked. So there are m such documents, so we represent documents by x and the class levels by y. So there are set of m documents whose class levels are marked. And what this learning system provides is, it gives a function f which sort of maps x to y, which produces, given a x, produces a y. So we have to generate, the classifier has to generate this function f, this mapping function f. So what are the situations where these class levels are useful? So we have many examples. Let us take some. Say for example, we have news articles. You know, a newspaper is categorized into, you have several, the news articles in the front page or something, then in the next page is foreign, maybe then national. So often you have categories. So for example, you are reading an online newspaper, there are categories like business, scientific, science and technology, sports, and so on. So the classes here, the job here is to, given a news article, you want to classify which category the article belongs to. So why this is useful? This is useful in many situations, like you are interested only in sports pages, maybe. So you want to obtain this level. Okay, so a more detailed case of this, for example, take a scientific article, say medical articles in Medline abstract. So you know, all the medicine, all the articles, they have categories. And there are names. For example, conscious sedation is a category E0.3.250. It is a category. So if you have ever used Medline, you will see each article is allocated a category. Earlier it used to be done manually, even now a lot of it is done manually, but a good system would be to automatically categorize this. Okay, alright. So another example may be, say a business, I am doing what is called business intelligence, and I want to find out what my competitors are and what industry they belong to. So looking at their blog or their web page, I want to classify what is the interest. For example, IBM, I might categorize as in computer industry. I have to, that's right. Okay. So there are so you see that there are some tasks which are really only a expert human would be able to do it. But they are belonging to this category. For example, I want to automatically evaluate an student's answer in an ACM, say GRSA or something. Okay, so and give a grade, say A, B, C, D or F. So can I automatically assign a grade? Or the most common example of classification which you might have seen is say classifying whether an email is spam or not. So similarly, you have say technical staff. You are working in a company and there is a mail from a customer, and you have to route the mail to the particular support staff who is expert in that area. You have to route that mail. Okay. So okay, there are other interesting things. So all of the first few you can see are kind of categories, like topics of them. But there may be other type of classification tasks. For example, I want to classify a document whether it is a research paper or a blog about a technical blog, or maybe a dialogue between two friends, or a deep article. So this kind of tasks. Or maybe I want to classify whether a document is written by an author or not. Can I look at a document and say that this person has actually authored this? This is called the author identification problem. So they also fall in the category of text. So there are one problem which you have already learned a lot is that looking at the sentiment, whether it is a favorable review or not, or maybe whether the paper is interesting or not, and even things like whether a joke is funny or not. So these are all the there are many others. So this is a vast range of problem where people have studied the applied text classification algorithms. Okay. The reason I gave you all this is that the text classification has indeed developed as a vast topic with numerous algorithms, and the actual algorithm which will work in text classification really depends on the finer aspects of which actual problem we are handling. For example, the algorithm which works for news article classification might not work for, say, joke classification, or a authorship identification. It might not work. There are certain things. So I repeat what has been said in the previous lecture, is that what I say is theory, but what will actually work in your problem will depend on the problem. So don't take any of this as a final word. Okay, so let me give an example. So this is people who are interested to actually work on text classification. This is a first talks, or this data set is available. You can also work in. It's called a Reuters text classification. So Reuters, as you all know, is a newswire agency. It collects news stories, and what they have done is that they have prepared a collection, a corpus, where you have a number of categories and some news articles which are categorized into those categories. And then what you have to do, so there are so many number of training documents and some text documents, and each of certain length. These are stories, and then 93 classes, and then you have to predict which class it is. So this data set is available. Anybody can download it and you can try. Okay. So now coming to the method. So I gave this example because I will explain the further thing. There are several methods for classification. The methods we will talk about today are actually called supervised methods of classification. So what does supervised method means? That it is like, as I have said in the first slide, that there are already a number of documents whose class level are known. Usually they are obtained by a human expert. So some human experts have marked a number of documents, and these labels are called supervisions of the algorithm. They supervise the algorithms. Okay, and using them, I train a classifier which I use in future cases whose class level are unknown. Okay. So there are a number of supervised learning techniques. The simplest is what is called a naive-based classifier, which I will talk about in details. And there are extensions to it, which is called the k-nearest neighbor and the support vector. And also some recent methods like boosting, which if I get time I will go. Plus there are many other methods. But note that all these supervised methods require hand-classified, human-classified training data. And but the good thing about this, most of this data don't need experts, can be built by amateurs, and these algorithms have the statistical capability to correct the noise in this annotation process or this leveling process. Okay. And actually what happens is that if you look at commercial systems, most of them do not use a single of this, but they use a combination of these techniques. They use some mixture of these techniques. Okay. So let us start with the simplest technique, which is a naive-based classifier. Okay. So before coming to that, each of these techniques basically gives you a function f whose input is a document and the output is the class level. So now the question comes that how do you actually represent this document as an input? It has to be in some mathematical form. Okay. So ideally the representation should be something which captures the information of the document in the particular concept. So if it is authorship identification, it should capture the aspects of authorship. If it is topic, it should capture the aspects of the topic. Okay, so it should capture this. But again, there are constraints. Like you need to very fast process this. You need a mathematically nice way of formulating this. So usually it is a balance between the two. That means whether you have an accurate representation of capturing of what you are trying to do versus what is an useful and simple representation. A nice data structure which will allow you to very fast manipulate this and which is very intuitive and easy to handle. Okay. So it is a balance of these two, what representation we get. So now the most popular representation, as you again know, is something called a bag of word representation. So what I said that this representation should be such that it should capture the information of this document. And what this bag of words assume is that the information of the document is actually inbuilt or embedded in the words present in the document. This is the fundamental assumption. The content of the document is contained in the units of information, which are the words. So this view actually you should think of it like this. So a document is like a container, a urn, and these words are units. You can consider them as balls or marbles of different colors. So a document is a urn, a box where different words are put in maybe one copy or maybe multiple copies are put in. Okay, and the content of this box is the content of the document. Now it turns out that while in different classification problems we study, all words are not equally information carriers. There are some words which carry more information than others. Okay, so you have to decide which balls, which words you keep in these urns. And this, which balls you keep in this urn depends on all this whole range of problem I talked about. If it is topic, maybe a newswire classification, maybe the topical words are more important. If it is a authorship, maybe, so in a topical document, maybe stop words like is, and, or, these are not important. But whereas in authorship identification, maybe the stop words, use of the stop words are very important. How I use this, what type of mistakes I make in you doing this. Okay. Similarly, sometimes called a stylistic analysis. So similarly, in doing, say, for example, sentiment, there are some words which are very important, whereas they are not important in news story. So the whole idea is, which are the information units you would like to keep in your, used to represent the document. Okay, so here is an example. So for example, in this case, I decide that it is only these highlighted words which are representative of this category or for this classification problem. So what I do in my information holder, I keep only these words and nothing else. I keep only these words and nothing else. Okay, so my bag of word representation, I am repeating what you already know by now, is that the bag of word representation of this would be a vector where components are these words and the values of the components are how many times this word occurs. Okay, so now what we have now is that we have when we are talking about supervised learning, we have several such documents with words present in them, only the informative words present in them, and then there are class labels which are manually marked. Now what I have to do, a new document comes, I have to tell, maybe with certain probability, that what class it might belong to. Okay. Okay. The simplest way to do that is by using what is called a name-based classifier. Alright. So what I do in a name-based classifier is very simple. I take this vector. Remember what this vector is? This bag-of-word vector is that a list of words and the frequencies of that word appearing in a particular document. Right? So what I do, so now I say that my document is nothing but a set of pairs like this, a collection of pairs like this. So the word grain 3 times, the word wheat a single time, the word D 6 times. So this is my X, the document. This is my document. Okay, and then what I do, I know what are the documents belonging to a particular class. Maybe the documents belonging to all agricultural stories will have a lot of this wheat, grain and this ones. So what I do, from these individual frequencies and times they occur, I count, I want to find out in the total category of agriculture, what is the probability of these words occurring. So to be more precise, I look at this conditional probability. What is the conditional probability I look at? I look at that, suppose I randomly pick up an agricultural document, a document with Y equal to say agriculture. What is the probability that this particular vector, that is grain 3, wheat 1, D6, will be present in that document? So I tell it again. So the idea is like this. You focus on this probability. That means I have a set of agricultural documents related to agriculture. I randomly pick up one agricultural document and I want to see what are the words it is containing. And then I take another vector of words, another collection bag of words, and tell me what is the probability that this bag of word is actually representative of the agricultural base. So that is what I am interested in, right? So say, so I'll try to compute probabilities like this, that what is the probability grain occurs 3 times, wheat occurs 1 time, given the document is about wheat. Or what is the probability that this, given the document is not wheat. These 2 probabilities I want to calculate. And then why I am calculating this probability? Because when a new document comes, whose y is unknown, but x is known. Because x I can always calculate. I know the word content of the document. Okay, I calculate x. I know that vector. I just count how many times each word occurs. And those set of words occurring, those probabilities I calculate for wheat and non-wheat. Let's say the classification problem here is simple, whether an article is about wheat or not about wheat. Okay, so I calculate these probabilities, and whichever probability is higher, I classify in that class. Okay, whichever probability is higher, I classify in that class. So the fx, my fx is nothing but the class level. It is that y for which this probability is max. I am coming to this modification. Okay, all right. So so this is the thing. Okay. But there is one problem with this approach. The problem with this approach is that maybe the set of documents you are classifying is mostly consisting of wheat or agricultural documents, has very few of non-wheat documents. Okay, so even though the word this grain, wheat, others appear a lot number of times, the still document is not about wheat, maybe, because it is not about, the whole collection is not about wheat. Okay, so we have an additional term which is called a priori probability. That means it is like the blind probability. That means without looking at the document, just given a collection, if I ask that if you are blind and if you pick up a document and ask this class, my answer will be y. So let me take an example. Suppose I close your eyes and give you a newspaper and ask you, what is the topic of the first page articles? Is it political or sports or something? Most probably your answer will be political, even without reading it. Because you have found that over history, most of the time the news headline is about political news. So this probability, without actually looking at the content, is called the prior probability. It is the previous expectation, prior probability. Okay, and this one, the other one, that means just focus on this last term. So this is the prior probability, and this probability x given y is called the class conditional probability. Why it is called class conditional probability? That means given a document belongs to a political article, what is the probability of these sets of words appearing? What is the probability of election appearing? What is the probability of prime minister appearing? Okay, what is the probability? So this is called the class conditional probability. And we can see that if you multiply class conditional probability with prior probability and divide by something of probability of a set of words appearing, then by base rule, the base rule of conditional probability, you get what is called a posterior probability. What is the posterior probability? That means given a set of documents given a set of words are present in a document, what is the probability the document belongs to a particular class? This is called the posterior probability. So you have the class conditional probability, you multiply it the a priori probability, divide it by something, and what you get is a posteriori probability. Note that, see, this posteriori probability is more useful in classification. It is more, because it says that given this set of words, what is the probability it belongs to a particular document. Okay, all right. Now you might ask that why I am not directly working with this. I am giving you an example, then this will become clear. Okay, So what is my net-based rule? Net-based rule says that take your training set, take your set of labeled class labeled documents, calculate these probabilities for each of these classes, and whichever class has the highest value of this posterior probability, classify the document to that particular class. Okay. All right. So if we okay. So tell me, suppose I have this document. If this document is presented to the name-based classifier, or sorry, not name-based, the base classifier, how would I classify? So let me summarize the approach again. Take 100 articles from the class agriculture, or say political news, and take 100 articles from the class say non-political news. Okay, and put together all these political news articles, calculate the probabilities of this collection of words appear by actually counting how many times they occur. Okay, and when this new document is presented, for the political you count what is the posterior probability of this particular set of words in the political news. Similarly, for the non-political news, whichever probability is higher, you classify it into that class. Right. So if I write down, if I actually have to implement, what I have to actually do is that I have to, out of these 100 documents, I have to find out, I have to count how many times a document has appeared where this particular collection of words has happened. This particular, see, I want to calculate the probability that in a political news these words will appear. Okay, so I have to, out of 100, if I see in 20 this collection of words has appeared, then 20 by 100 is the probability, posterior. Okay, but the problem with this approach is that usually you will not find in a 100 document any document where all these words have appeared. You'll never find. You have to maybe take 1 million documents to get sufficient number of documents where this particular combination, in conjunction, all this will appear. The conjunction probability, you know, is much less than the individual marginal probabilities. Okay, so so your estimates will be bad. As a result, your that posteriori probability calculation will be erroneous, and your classification will be wrong. So how do you get rid of this? People get rid of this by making an assumption that the probability of these words appearing together is same as the probability of these individual words appearing and product of them. So basically, you assume that probability of word grain appearing in a document is independent of the probability of word oilseed appearing in a document. They are independent. Okay, and you know that if you have probability of 3 variables, let's say A, B, C, probability of A and B and C, if A, B, C are independent, is probability of A into probability of B into probability of C. Okay, so probability of all these words appearing together is nothing but the product of the probabilities of these words independently appearing on them, which is more common event. Which is a more common event. So if you take 100 documents, you are going to get sufficiently good number where the word grain or the oilseed has appeared individually. Okay. So what the name test does is that it calculates this joint probability of these words appearing together, given a belongs to a class, as a product of these individual words appearing in this particular class and the product. Okay. So this assumption holds only when the words are independent of each other. They do not, the one word appearing is independent of the another word appearing. Okay. So I calculate this. So how do I calculate this probability? So this probability, as you can see, is nothing but the ratio of 2 counts. What is the numerator count? Numerator count is that how many times the word W has appeared in a document whose class level was Y. So basically, I take all the political news and count how many times the word election has appeared in them. That is the numerator. Okay. And what is the denominator? Denominator is out of the total collection, how many are actually political documents. Okay. So this ratio is basically a fraction. How many fraction of the document this word has appeared. Okay. So this is this. And so I do this for each word in the new. So if I have a new document with say 70 words, for each of these 70 words I calculate this, take their product and compute the posterior class conditional distribution. Okay. And from the class conditional distribution I multiply the prior probability and get the posterior distribution. Okay. So now there is a problem. Suppose the new document contains a word which has not occurred in any of the previous or the training set. Okay. Which means the numerator is 0. And since this is a product, even if a single of these terms are 0, the entire terms become 0. Entire product becomes 0. Okay. So a single new word can actually sort of collapse the baseless pair, baseless pair. Okay. It will destroy this. But this actually is not a problem of the net-based class. It is actually a problem of the training set you have taken. It is not a representative of the class. Some words are not obtained. Okay. So how do you solve this, or how do you correct this problem of the training set? You give a proxy. What you do is that if some word is not present, you assume that there is a proxy for this word present in the previous. Okay, so for example, I have taken 100 documents about political, and there is a word, say Arvind Kejriwal, which has not occurred in, because my data was about 10 years back, and Arvind Kejriwal was not there, now that term has appeared. Okay, so how do you do about it? You give a proxy for Arvind Kejriwal in the previous data. You randomly put in the word. You don't know, they have not actually occurred, people have not written, but you artificially insert that word in the previous document, so that you don't get a 0 score. So how that proxy is actually given? So the problem was that this numerator was 0. So I don't make it 0. Instead, I add a small number. I add a small value, which is m times p. I introduce two parameters m and p. I add two values. I add mp here and m here. So actually, I mean, we'll see later that this thing comes. These values of the probability comes from something called a multinomial distribution. And if you make this change of these small values added, they are sometimes called Dirichlet priors. That means you sort of say that even if Arvind Kejriwal is not there, my prior experience says that it is like this. Actually, this process is called smoothing. This is a common technique in probability where you sort of calculate the probability of a rare event by a more common event. I'll take an example. For example, say Harbhajan Singh is playing Shoaib Akhtar in the last ball of a match and he hits a 6. And you want to calculate the probability of what run Harbhajan Singh will score when he faces Shoaib Akhtar. Definitely it is not 6. But since you have, but based on this single example, it would be 6. But 6 is not a realistic value. So what I do, I replace this 6 by the previous average of Harbhajan Singh playing, and this broader event, maybe the average value is 0.2. So the actual value would be this 6 plus 0.2 divided by something, this total plus this, which is a more realistic estimate of the score Harbhajan Singh score. Okay, so so this process is called smoothing, and these are called smoothing parameters, sometimes called priors also. So this is what is called a Dirichlet prior. Okay, so m and p are two parameters. So even if some word is not appearing in the training sample, this would not give a 0 score. It would not give the absolutely accurate score, but it would give some reasonable score. Okay, so usually, I mean, in many experiments, people have used one common practice, which is called a Laplacian smoothing. They use m to be 1 and p to be 0.5. if we put together algorithm, I mean stepwise, what it turns out that this I think this is the takeaway from this entire story I said before. So what you do, you take all documents having a class level Y. Say for example, collect all political news stories, and for each of the word in each of the word WIJ that appears in a political news story, you keep a count. So if you take a word versus document matrix, you increase that count. And also, so this is the count which is useful for the class conditional distribution. Similarly, you count how many of them are actually having level 1. This is the after I probability. And also you total count how many documents you have seen, that count. Okay. And you see, if you take the this probability, if you take the logarithm of this quantity, which is same as taking this quantity, since you are taking maximum of this anyway, is the sum of the logarithm of this individual terms. Okay. So you just calculate the logarithm of this count by the total count, which is the probability, plus the sum of the logarithms of the class conditional counts divided by the count of the class 10, and